All right, in this lesson, we're going to take a look at arithmetic series. Now, the only difference between a series and a sequence is a series is a listing of all the term values. Sorry, a sequence is a listing of all the term values. A series is when you take all those term values and add them together. So you can always tell the difference where in a sequence, all the terms are separated by commas. In a series, there's going to be a plus or minus between every term to indicate that we're taking the sum of all of the terms that exist in there. So if I have this sequence of 3, 5, 7, 9, and 11, then the series would be 3 plus 5 plus 7 plus 9 plus 11, which would give me a sum of 35. Anytime I see Sn, it means that I'm taking the sum of that many terms in the sequence. So anytime I see Sn on my formula sheet, I know that those formulas are only used for series. They are not used for sequences. It's not going to tell you what the individual terms are. It's going to tell you what all the terms up to that point added up will be. To illustrate the method of determining a formula for the sum of n terms in an arithmetic series, the story of the great mathematician Carl Gauss is frequently told. When Carl was about 10 years old, he was placed in Master Buttner's arithmetic class. Master Buttner often gave his class a long arithmetic problem to keep them quiet for a time. On one day, he asked his class to add the whole numbers from 1 to 100. While all the students began to work madly on this assignment, Carl laid his slate on the desk and informed Master Buttner he was finished. Master Buttner asked Carl what his answer was, and to his astonishment, he gave the correct answer of 5,050. Here, we can apply a method similar to how he determined his answer. He said that if he started at 1 and went up by 1 each time, he would have 1 plus 2 plus 3 plus 4 plus 5, all the way up to 100. If he wrote it in descending order, then it was 100, 99, 98, 97, 96, 95, and then so on and so forth. What he did was he vertically added the rows and found that if he took the first term and the last term, they added up to 101. If he took the second term and the second last term, it also added up to 101, which means that every single term added with the equivalent term in ascending or descending order always gave him the exact same answer. Now, he took all the terms added together, and then all the terms in descending order added together, which means because he added this entire series twice, he said that this would be double the series. He also said that there was 100 numbers in the series going from 1 to 100. So he simplified it to say that 2 times the sum of the series would equal the 100 terms times every sum was 101, where 2 times the first 100 numbers was going to be 10,100. Then all he had to do was divide both sides by 2 to say that it was going to be 5,050. Now this is a lot faster than adding up all of the individual terms. This would work for any arithmetic sequence. If I took the first term plus the second term plus the third term, or I took the last term, the second last term, the third last term, and I add them together, the sum of the first term and the last term is going to be 2a plus n minus 1 times d. If I took the second term and the second last term, it's also going to give me 2a plus n minus 1 times d. When I simplify this, it just means that 2 times the sum will always be the number of terms times the sum of the first and the last term, 2a plus n minus 1 times d. That's always going to be what the sum of the first and the last term are. And then the sum of the terms will always require me to just divide by 2 at the end because I've added every single term twice. Now, we know that this works, and remember on our formula sheet we use a is t1. When the common difference of the series is not known, we can create another formula where if I don't know how much each term is changing by, but I know the first and the last term, then I can simplify it by just saying, take what the value of the first term is and the value of the last term, add them together, multiply that by how many terms were in the sequence or series, and then divide that by 2. One of our formulas includes solving the value of the last term. One of our formulas is just based on if we know the value of the first and the last term. So if it says, determine the sum of the first 14 terms in this series. In this case, I can say that my first term is 9. I know that my common difference would be 15 minus 9, or it's going up by 6 every single time. I don't know the value of Tn, so I can't use the second form of my formula. But I do know that n is going to be 14 for 14 terms. So I can plug that into my formula and say that the sum of the first 14 terms is going to equal the number of terms multiplied by 2 times the first term, which is 9, plus n, or 14, minus 1, times my common difference of 6, all divided by 2. When I plug it in and double check to make sure that I put it in my calculator properly, that's going to give me 672. Alternately, if I'm asked to determine the sum of the 22 terms of an arithmetic sequence where term 1 is negative 18 and term 22 is 45, then in this case, I know that term 1 is negative 18. I don't know what my common difference is. I know that my Tn, or the value of the last term, is 45. And I know that my n is 22 for the 22 terms in here. And then I can put this into my formula. The sum of the first 22 terms is 22 times term 1, which is negative 18, plus the last term, which is 45, all divided by 2. And I don't even need to solve for what the common difference is. And this is going to give me 297. Now, one of the things that is common in both of our arithmetic series formulas is in both cases, it does require that we know n, or we know how many terms are in there. So if I'm given something like this, where it gives me t1, it gives me tn, I don't know how many terms are in here, but I do know what the common difference is, because it gives me enough terms to solve the common difference. Then I can say that t1 is 17. The common difference is negative 5. Tn is negative 38. And now I need to determine n using my sequence formula. I'm going to take the Tn is equal to T1 plus n minus 1 times d, because I have my Tn, I have my T1, I have my d, and I can use this to solve for my n, which I always need. So if negative 38 is equal to 17 plus n minus 1 times negative 5, I'm going to subtract T1 from each side and get negative 55 is equal to n minus 1 times negative 5. I'm going to divide both sides by negative 5 and say 11 is equal to n minus 1. And then I'm going to add 1 to both sides and say that 12 is equal to n. So I know that there are 12 terms in the sequence. Because I know the value of the last term, I can use my second form of the formula. I could do it with both, doesn't really matter. But I'm going to say that the sum of the first 12 terms is going to be 12 times term 1 plus term 12, all divided by 2. And the sum of the first 12 terms will be negative 126. So sometimes we'll have to use both formulas. We'll need to use the sequence formula to solve for key information that we need in order to use our series formula.